Hello everyone. Today we're going to go over how to use a BCD module. So in a previous video we went over how to make a multiplier and a 7-segment controller. But if we have a result from an arithmetic module like a multiplier or an adder and it's in fixed point format, like for example, let's say the product is 16 bits long, has one sign bit and 5 bits for fraction, we cannot just pass that value into the BCD and expect it to drive these two arrays right in a way that will generate the 7 segments to show the value that it is. It's not going to do that. What we need to do is pass it through this module, the BCD module, to convert it into a format that can be used by the 7-segment controller module to correctly drive it. So it's not too bad. Let's assume in this test bench, we're going to assume our value to be converted into the correct format from an assumed arithmetic circuit before being passed into the 7-segment controller. We're going to assume that result from that arithmetic circuit is 16 bits wide with 5 bits of fraction. So we're going to send those two values in and see what happens. So we're going to set the radix RBN by the fractional point is. So for this first one, it correctly converted -12.625 into the hexadecimal values, and it also has the sign bit as 1, meaning it's negative. For this second one, it correctly got the first 2 bits of the integer and all the fraction bits right. The test bench, if we wanted to calculate more bits for the output, for the integer part of the output, we would just increase it. It's like 4. Let's run it again just so we can show you that increasing the number of integer bits allows you to get all the digits if there's a lot of digits. Let's change the radix. So now you can see that it captured all of the digits. So now let's say we want to display -12.625. What we would do is -12.625, that's our P, that would go into BN. This BCD is going to drive the sign high and update these two values. And this sign and the BCD int and BCD frac are going to go into the 7-segment controller. And the sign bit is going to be treated as like an input indicating to display a negative sign if it's high. It's going to be equivalent to the special case register that was discussed in the video where this module was made. And the BCD is just going to be the concatenation of BCD int and BCD frac from this value. Then if you do that, it's going to correctly drive, that module is going to drive these two arrays to show -12.625 in the 7 segments. And the same thing for this one. So yeah, using this binary to decimal, this BCD module, you can convert any result from an arithmetic circuit into a format that can be displayed on the 7 segments using this module that we made. And it will always work. So whether it's an arithmetic circuit or your own circuit, any fixed point value can be converted into a format that the previous module that was discussed in the last video can correctly put on the 7 segments. So that'll really help you to display the results of any calculations that you have and any FPGA-based projects that you do. And as usual, all of the code is provided in the description.